Okay, do you try to fill that out? What is sine 30 degrees is? 0.5, agree, 100%, no? So we don't have any doubt from the beginning we know. And you can see, if I click 30 degrees there, can we figure out 150 also? Now why did I moving, why I'm shifting from 30 to 150? So as I said, you can always remember, if I have this unit circle, where is so reference angle, so if this is 30, if this is 30 degrees, which is the other one? If you reflect it on this side, so the main ones you should know is, what is this one? 30 is x and y, right? Agree? First is x cosine 30, so this is like cosine 30, and this is sine 30, right? And cosine 30, we say, okay, root 3 over 2, and this is half, right? That should be at the back of your mind continuously. So that's 30 is half. But if that is half, sine 30 is half, think of another angle on the reflection, see this? That also is 30, can you see that? And what is this angle? How many pi by 6 there? Remember, so the whole round is how many pi by 6? 6 of them, right? So that means if this is pi by 6, what should be this one? What I'm trying to say is, if this sine 30 is half, because of this 30, you can also say this, the second number will be the same, right? If this is half, and this angle that you see, the reference angle is 30. You know, the reference angle means the terminal side. This is the terminal side. So this is the terminal side, right? So that's why sine 30 degrees, and what is this angle? What is that angle? How much is this angle? This much. Remember, I'll tell you the truth. Most of the teachers, they want the graph. You just watch that and graph it. That's it, done. But no, I want you to really do it actually how it is. So if this is green color pi by, that is 0.5, then this also takes what? Where is that? This one, can you see? This also takes what? And one more thing I want to observe is, this part is the first quadrant. Can you write down quickly? That's this part is which quadrant? Second. I think that's another way to know whether the sign is positive or negative. What about this one? The third quadrant. And this one is the. So right now we are focusing only on the sine, S-I-N, not cosine, the y coordinate. The whole round on the unit circle, our focus is the second number. So what do you think this one will be? 7 pi by 6. I know 7 pi by 6 is like an alien, but remember, just think of pi by 6 is 30, right? 730 is, where do you go? Where is this angle 730 means? Halfway down is 6 pi by 6, agree? 6, 12, right? So 12, 30s make you the whole around. So I want to know what is this one? 7 pi by 6. Where are you on? Which quadrant are you on? Third quadrant, right? So remember, this is minus plus. Anything here is both minus. Anything here is plus and minus, agree? Kind of getting it? Let's really get the main graph actually. If you know the main graph, then we can just work, the rest is just kind of robotic means you just kind of do work. Understanding this is important. So my question to all of you, what do I put here?
Negative 0.5.
Why negative 0.5?
Because it's in the third quadrant and
Yeah, so this is like, you're thinking a lot in your mind, right? Oh, x, y, sine, sine 30. And it's just a reflection. So if this is half, this also is half, but this one is negative. See how it works? Cool, right? So that's 7 pi by 6. It's like this is all the way 7 pi by 6. This is 730. Oh, it is also 210. Where is that? Can you see that 210? So the top numbers are easy to understand. You just go on adding 30, 30, 30, 30. You're just adding 30 degrees. That's easy, but when you write in the radians, that's become difficult. Correct? On my S.
Your video stopped recording because it has no battery.
Oh God, is that happened? The whole life is over now.
No.
I think I have to put it like, it just stops and then continues, right? Okay, I put the thing. Natalie, you want to say something to capture the?
No.
Say anything about me.
I know, sir. Mr. Bello is such a great teacher.
Oh my
I
God.
love learning.
What's your account number?
I'll give it to you right now, Mr.
Hugo doesn't want to say anything. He say, get lost together. You don't even give me good point. I had him in my freshman, so I know him very well. Right? Hugo? Yeah. I think all of you except Bianca.
Sorry, I had another teacher.
I enjoyed teaching that. What is that? Geometry was my best. I used to like that geometry. Okay. How come we can't record, pause and continue on this? I asked they call it a smartphone. Huh? Yeah, they call it like a smartphone, but it doesn't have that pause and stop and continue, right? Have you seen that? The camcorders are the best. You just can pause and then do. You know the camcorder like that. Okay, let's do quickly. This is not difficult. I've already made my everything ready. We just fill that out. We put the points and graph it. And then we want to see how the graph look like. So, this is 0.5. What is this part also? Is negative 0.5. Are you agreeing with me?
Yeah.
Of course, you could write negative 1/2, 1/2, but because of the, I want to mark those points at 0.5. That's my point. Main thing is this is 0.5. That's why. Now, and then finally we go to another green color. Look at this thing. 11 pi by 6. All around is 30. So 12 of them. So where is 11? So this will move something like this. Can you see that? So 11 of them. Just one less. So this actually it is 30, but it is 11 30s. 11 pi by 6.
It's again negative 0.5.
So it's going to be that part, right? Because y is always the SIN. So, make sense? So minus 0.5. Agree? So far so good. We finished with the green color. Let's finish with the blue color. So what is the meaning of pi by 3 means? 60.
60.
And from that original, remember I used to always say, hey, remember what is sine 60 is? What is sine of 60 degrees is root 3. Okay, now what are we going to do is we'll try to get actual value of it. What is root 3 means actually? Square root of 3? You want to calculate or it? These are few things you should know. Square root of 2 is 1.41, something like that. Pi is 3.14, agree? Those are irrational numbers. And also you should know is E 2.718. Remember that E is exponential. When something is growing, bacteria growing is y equals, and I give you my shortcut formulas a long time, you forget. But my point I'm making is these are like irrational numbers. So root 3 is another number. It's always better to remember 1.73. Can you write down that? Always, of course, it is 1.73 and blah blah blah, I don't know what. So main thing is 1.73. So if I take a half of 1.73, what do you get? 0 point, somebody quickly?
889.
It's recording, it's on, right? Oh, I have to sign in. So I will put this also for the honors algebra too, the other teacher who is sick, no? So it helps everybody.
6.
Huh?
0.86.
0.86, yeah, correct. 0.86 and 5, we'll round it to 0. Approximately. Make sense? So where is this? So let's put 0.9, right? It's not 0, it's approximately 0.9. Agree?
Yeah.
What about the other blue color, 120 degrees? So if I say 120 degrees, which end, where are you on? How many pi by 3s?
3.
Yeah. How many pi by 3s make a circle? Now, I know, the moment we say this, it's better that we do have to know that pi by 6 is what? 30 degrees, right? So 6, sorry. So in order to complete the whole circle, there are 12 pi by 6. Make sense? 12 of them. If it is pi by 3, it is 60 degrees. How many of them are there? 6 pi by 3. Make sense? All around. Kind of little thinking, a lot of thinking. Takes a while, but don't give up, you have to. When you become another 10 years, you can make a lot of money tutoring students and going to college. Make sense? Nobody knows this. I mean, nobody wants to learn trigonometry, this part, nobody wants to do. Okay, so that's why, what I'm talking about is 2 pi by 3, where is this 16? Pi by 3, where is pi by 3? So if this is 30, 60, this is like 60, right? So that is one of the pi by 3. And 3 pi by 3s make the whole thing. So this whole thing is 3 pi by 3, right? So if that is 1 and then 2 pi by 3, agree? Make sense? So you kind of thinking, you have to think, oh, okay, 1, 2, like, oh, second, that's what you have to think in your mind. So if it is the second quadrant, remember it is why the sign is positive, agree? And sine 60. So you use the same thing. What you did for pi by 3, you also do the same thing for 2 pi by 3. And the reason, they have the same height. See this part? For this angle 60 degrees and also for 120 degrees, their height is the same, the y value. See that part? Only it's like in the second quadrant we put it negative. Same height, right? So reflection over the y, so like that. So the reference angle is this 60. So you knock off this, the 2 and think of only pi by 3. This 2 only helps us to locate where does it go. So what do I put here? 0. Okay, this should be blue color, right? This should be blue. So 0.9 and that is 0.9, agree? See, we could have easily used calculator and get the answer, right? Just like that. We can, but that's not how it is. We have to really get this one. Then what about 4 pi by 3? Where are you 4 pi by 3? Which quadrant are you on now?
The third.
The third? You go all the way 3 and then 4, right? So you're going, okay, 3 and then little down. So this will go, so this will go. So if that is 60, so this will be somewhere maybe something like this. Or not this one, maybe 60 will be quite a little bigger. Oh, so that's like 60. See, this is 60. So because there are 3 already here, there are 3, right? pi by 3, pi by 3, pi by 3, and then 4 pi by 3. So 1 pi by 3, then another pi by 3, and another pi by 3, and another one. See? So 1 pi by 3, 2 pi by 3, 3 pi by 3, 4 pi by 3. Is that right, Natali? She's like, okay, I'm still hungry, Bella. Just can you do it a little faster? No. You're not thinking like that. I know sometimes you understand, and my wife gets upset. You know, when I tell her at home, no, I'm teaching my daughter. You know, my daughter is in the North Basis High School, elementary school. No, she's in the North Basis. And she has some math equation inequality, already inequalities are there. You know, and I'm trying to show her, I'm trying to blah, 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 blah. And she already got it. I'm still blah, blah, blah. My wife, why are you showing so much? She already got it. Go next. I said, okay. And then she said, okay, I got it. Dada, I got it. She said, Dada, I got it. Okay. So the blue color, this 240. What is 240 is now? So this is the one, right? So again, you are in the thing, and remember the 2 pi by 3. Pi by 3 is 60. Sine 60 is 0.9. So this also has to be what? Is it minus or plus?
Negative.
Third quadrant, both are minus, right?
Yes, sir.
So it has to be minus 0.9. Did you get that?
Yeah, it's the same for pi of it.
And then it's the same, but this sine pi by 3 will be what?
Negative.
And it reflects this side. See this part? So like this. So that's like 60 again, and this goes all the way. How many pi by 3s? 5 pi by 3. See that? So 3 of them here, and another 2, and you land up there with the plus and this one, the old one. Don't get confused there. This is plus. So what is this answer?
Negative.
It is going to be negative 100%. We know. Knock off. So when this happens, this sign is only because of where the quadrant it lies, and knock off the 5, pi by 3 stays. Do you see what I'm saying? Just think of, hey, 5 does not exist. So pi by 3 is 60, and sine 60 is 0.9. Agree? Okay, now the other ones are quadrantal. Quadrantal means those are the easiest one. This side is 0.1, this is 1,0. Who doesn't know? Everybody knows, right? And these are 0, 1. So what it means is quadrantal angles are easiest. Are you guys getting what I'm doing? 100%? At the end, you will speak good about something, the lesson, no? Feelings? Feelings. You heard the song? Nothing more than feelings. You never heard? Feeling. Oh, no, never? Oh, you heard only calm down. And then a little girl dancing and just throwing things around like that. Yo. You did not see that on the TikTok? No, you guys don't see all that. Funny videos come on. Okay, let's finish now. This is easiest, and now we are already done, and that's it. So the main thing is sine graph, then you can do the cosine graph yourself at home. So first, remember, this is the y, my focus is y. And what is that y basically means what? Yeah, the sine. So my focus here is, we are not worried about this part. On the x-axis or the y-axis, this is sine of 0, right? This is sine of, what is this angle there? Pi by 90 degrees? No. What is this one? I. What is this one? 3 pi by 2, agree? And what is all around?
2 pi.
Yeah, 2 pi. Got it? Got it, right? So let's start with this one, sine 0. So we start with sine 0. The red color I'm using here. What is sine 0? So basically you're asking what is sine 0 is 0, correct? It's on the x-axis. So 0. Now this is these are all radians here. I'll just put a small c because of the, radians are, radian measure is like how many radius fit in the arc kind of, circle. So they use a c there. So c, 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 c. So this is 0, this is 0 raised to c, and this is the value. Can you see the difference? So this is degrees. So there is a difference between this 0 and, okay. Now, what about pi by 2? What should I write? 1, 100%. Jocelyn, can you just tell her why?
Because the sign of it is 1.
So when,
You
and it's to tell you the truth, if you understand this, if you feel nice, got it? There's something nice there. It looks stupid for people who don't understand. What is this kind of thing, right? In physics, they have a lot of, even the waves in the ocean, the high tide, they are going like that. We will be seeing those kind of problems later on, but that's like connected. Even the temperature, like see the lowest it goes now is like minus 27, sorry, it was 27 today morning. Do you know today was 27 degrees?
In the morning?
Yeah, and you can think even of a graph. See this part? So like this is Jan and this is Feb, and we can see this is 27. Let's see, this is 27. March, April, May, June, July, August, September, October, November, December, Jan. Jan comes again in Feb. So basically what happens is this is the lowest it goes. Something like this. Can you see? So the graph, it is the lowest, then it goes up somewhere, then it goes down. So that's the highest temperature, maybe February, March, April, May, June. I think it goes like this. Something like this. And then back to January and February, again it goes like this. See how of course this is stupid what I do. What I'm trying to say is, as the months pass by, the average temperature goes on increasing, and somewhere in March, April, May, and June, and this is not correct. February, March, April, May. This is June. This is July, and July is the maximum temperature. So maybe something like this here. So July is the maximum, and then it goes on down again, and somewhere in something like July, August, September, October, November, December, and January, and again goes to the lowest. You see that? This is not a perfect graph. So what I'm trying to say is, in real life, we have a lot of situation in temperature also. Okay, so let's finish this. Where are we? What is sine 90? 1. Agree? Sine 90. What is sine 180 or 2 pi? Sorry, pi. So the red. So this is 1. This is 0. Everybody agrees why it is 0?
Yeah.
And remember on the x-axis, the best way to remember is x-axis here, this x-axis here, sine and tan are always 0. That's how I remember on the x-axis. Okay. What on the y-axis? What happens? They become either 1 or minus 1. So what should be this? Okay. And then you go back to the same place. What is this? Back to the same 360. You make a hole around. Get back the same place, so it has to be 0, agree? And what is the next is, then the whole thing repeats. You see the whole, you're back to the 360 degrees here, and if I write another 30, maybe 390, and then, what is this, 420, 10 or 20? 360 plus 30 is 390? 390 plus 30, 420, 450, plus the 480, and it can go on. We're not worried about that part. So what is important is this, whatever returns as answer, they will be repeating. Can you see? So from 0, and the next one will be the back to 0.5, 0.9 like that. Because they become co-terminal angles. So once you have 390, so it means this is 360, right? And whatever was 30, this was 30. Now, this is 390, agree? So 30 degrees and 390, the terminal side is the same. Got it? So you go all around and go back to the same place. You get the same y coordinate, so that's the half part. See? Make sense? So this half, of course, we are not writing that. We don't want to do. What is important is just, okay, then the same thing continues. And that's why we will say, hey, 0 to 360 from 0, whatever the graph. Got it, what I'm saying? We are almost finished. Somebody texted you. Boyfriend? Handsome? You have a girlfriend? You go? No? Liar. No, I'm just kidding. He said, how can you ask those questions, Rebello? We are recording and putting me on blast. I'm just kidding. Okay, so let's put it right directly. Let's see graph. Did you make x-axis, y-axis nice and beautiful? Can you make it with a ruler or maybe ID? Just make it nice and beautiful. And I tried to do a big one. Actually, there was no need. I should have done a little smaller, but just wanted to see nice and beautiful graph. How the graph looks like. Sine graph. Is that okay? And then in between I'm going to write down, because green color is used for pi by 6, so this is pi by 6. So this one is 5 pi by 6. This will be 7, 6, and then 7 pi by 6. And then we have 11 pi by 6. So that was. And then also 60 degrees. So these are pi by 3. Then this becomes 2 pi by 3. Then let's stop. Pi by 6, pi by 3, pi by 2. This one is made a slight mistake here. This is 2 pi by 3. So 7 and 4 pi by 3. And the blue ones are.
Mister, you have 2 pi right there.
Somewhere I made a mistake. Can somebody tell me first?
It's where 2 pi is.
Huh?
2 pi, next to 2 pi over 3.
Oh, this one. Oh, this should be.
No,
No, next to it.
it's 5 pi by 6 after that.
1 pi by 6, 2 pi by 6, 3 pi by. This is correct, right?
Yes.
Then comes 2 pi by 3, correct? Oh God.
5 pi by 6.
Oh, I missed. So I have to take off everything. This whole thing, let's take it and extend it by 1. So let's go according. So this is 2 pi, 1, 2, 3. This should be what?
Yeah, 5 pi by 6.
Yeah, 5 pi. So green color. So I made in the beginning itself I made a mistake, right? You know what I'm marking? So what is the next one? 6 pi by 6, which is pi, right? Then
7 pi by 6.
then I have 7, 7 green color, right? I'm just using color coding just to get that whole thing correct, right?
Then
What is the next
4 pi
one?
over 3. 4 pi over 3.
So the blue one,
Blue.
4 pi by 3, then
And then black, 3 pi over 2. Black.
kind of racist here. Then what is the next one?
Is black.
With 3 over 3 pi by 2.
Yeah, sorry. Where is it? Okay, there it is. 3 pi, 390s, right? 3 pi by 2. What is the next one?
Blue and 5 pi over 3.
Yeah, blue 5 pi by 3.
And then green 11 pi
Then
over
green 11 pi by 6.
And then red 2 pi over 3. And 2 pi.
2 pi. So now it's so confusing, right? And that's why all teachers want to say, hey, don't even let it, just show them the full unit circle, the rounding, watch it and do it. That's it. But it's good that, okay, the main thing is, this is like 30, 60, you can also remember, this is how I do 120, then 150, 180. This is small, I like little small one here, 210, and this is 240, this is 270, that's 300, this is 330, and then 360. Agree? Yes or no? Okay? Now let's put the points, right? Let's put the points. So what is sine 0 is?
0.
Sine. Let's put all the red ones. Sine 0 is 0. Sine 180 also is 0. And sine 2 pi is also 0, correct? All red ones? Because on the x-axis, sine is always, you always have to remember, y coordinate is 0 on the x-axis. Second number is 0, right? That means sine is 0. Yes or no? Okay, what about the next one, 30? Let's put the
0.5.
green color. So 30 is 0.5. Can we mark this? 1 point.
5 pi over 6 as well.
So the next one is 5 pi by 6, which is 150. I'll remember because sometimes when I get confused, it's suddenly like you get lost. So that's where. So from
Positive.
so 0.5. This also is 0.5, right?
Yeah.
Because see, until 0 to pi, it is like 180. We are still in the. See, remember this is sine is positive here. Here also sine is plus. Here sine. This is another way to remember, and this is sine is negative. Correct? See what suddenly I try to confuse you. In the first quadrant and the second quadrant, y coordinate is positive. That's why the trig ratio of sine is positive. This is okay? And the second quadrant, third and the fourth, it is negative. So the next one will be 11 pi by 6. This one is minus 0.5. So this one minus is here. So I go all the way, mark here, 11 pi. Yes or no?
Yeah.
So these are for the green ones. Let's do the blue one. Oh, we are taking the whole class, right? But you get a lot of information, right? Jocelyn, agree? Bianca? Bianca, can you help me? Sine 60 is how much? The pi by 3 is?
0.9.
Yeah, 0. Now here we don't know exactly where is 0.9, so I'll try to make 0.6, 0.7, 0.8, 0.9. So you can just do your own kind of thing. We are not perfect here, but just let's see, maybe this one. Pi by 3, and then the other one is 120 is 0.9. So 120 is, this also is 0.9. Same height, so I have to do the same height. See this height and this height has to be the same. But then if you go other side, 4 pi by 3, that is 240, 4 pi by 3.
Is that 1?
I have not done the one part will be here. That's what I'm not done yet. I should have done that first actually, all the. Okay. Okay, the blue one, which one now?
4 pi over 3 and 5 over 3.
Yeah, this I'll make 0.6, 0.7, 0.8, 0.9. So this is minus 0.9. This is 0.9. And then here I go all the way, right? Somewhere here, right? See, I'm too close to the board and I can't do it properly. And this one is 5. Agree? 0.9, right? And let's put the other one, the red color. So the red one, no, the black one. What is the black one?
So 1 and negative.
I think I put,
One.
You put it.
yeah, I
Put
put
it as red.
red, okay, red, let's put it red. This 90 is 1, so if this is pi by 2, 90 is 1. Can you see that one? This one is 0 already, but and 3 pi by 2 is down at -1, agree? Okay? Make sense? And now let's see how the graph will. Of course, computer will do and say, oh, well, we spent so much time just doing this, there was on the Desmos, you just put it to see the graph. Right? But now you know exactly why the graph exists. Okay, let's graph the beautiful graph and start from here. See how it is? So it has to go through all this point. So it rises up. I want you to think this, see how it rises up faster. See, there is a steepness here, kind of if you try to draw a tangent, kind of, you know, the slope. In the beginning, this goes faster, slows down. Look at this, slows down, takes a turn, and then goes this way. Nobody say yes.
Yes.
Okay, and then it goes through this 180, and you can see actually here also when you go down, it increases faster, and then again it slows down. So this way it goes, slows down. Look at this. So it is going down, but at a slow rate. It's also going down, but slow, and then again it rises, speeds up, it increases, and that's it. Did you learn something?
Yes.
So the goal is, we did this only from 0 to 2 pi, but if we had to extend this, can somebody tell me what would happen if we extend this?
It would look like a wave.
Say it again.
Wouldn't it look like a wave?
Yeah, see? So if this was, I had to do, and maybe this is 4 pi, what will happen? So the same thing, what will happen? It repeats, that's it? Do you see something there? Simon? So that's why, what is this called? Is from here to here, this is this part. Because the cycle, you know, the graph, the same graph repeats every 2 pi. Can you see this? So from 0 to 2 pi, are you watching what I'm doing? Kind of an observation that, okay, that means every 2 pi, so the next one is again from here to here, the graph will be the same thing. Can you see that? And that's why this is called period. Can you write down what is the meaning of period? So we use the uppercase T to say the period of sine graph is there. And there's another word is used, amplitude. So the amplitude right now is like from 0, and you can see this part, how much it goes up. So look at this part. This is 1, can you see that? And this also is what? The distance is 1. So when you have the line, this is like a line of, this is called line of symmetry, means axis where whatever is up, only thing it goes down, but the main thing is I'm talking about is this is called amplitude. Can you write down this? So you will also see a lot of, next class we are going to see, okay, what about Mr. Bello? What about minus sine x? What about, this is what we'll be doing tomorrow, what about 3 sine x? What about y equals sine of minus x? See this part? What about if it is y equals sine of 4x? What about if it is y equals 3 or 4 sine of 2x? So this kind of things we will do next class. But today, we only want to understand, hey, that's the original parent graph of sine function. And of course, I did not show you on the left side. If I had to extend this way, the same thing would continue like this. Look at this. It goes this way. Can you see what I mean? And we will also see why it goes down. Is there's a next class is sine of minus theta is minus sine theta, and that's why it says sine is odd. Can you just take note little of this, and I will explain in more detail in the next class. What is that odd and what is the even and why it is going down this way. Okay, so your work, what are you supposed to do? Go home and do gx equals cosine graph. Can you do it yourself? I use all the y coordinate, remember? When we use this one, every time what I use the y, remember? For the cosine it is x. Okay. So do that and show me tomorrow to get your points for cosine. Can you see the cosine graph already there? But you have to make a table like this. Okay, thank you so much. And
Bye, Mr.
yeah, stay safe. Tomorrow I'll give you the engaged homework, yeah? Yeah.